Hello, everyone. My name is Brittany, and I was asked to talk with you a little bit today about COVID-19 and the testing protocols and go over some details with that. Um, coronavirus or COVID-19 is an infectious disease caused by a newly discovered coronavirus. The COVID-19 was originally discovered in Wuhan, China, towards the end of 2019. To which it rapidly spread, and it's become a global pandemic that we're dealing with to this day. Most people that are infected with COVID-19 will experience mild to moderate respiratory illnesses that will recover over time without recurring special treatment. Symptoms include flu-like symptoms like muscle, body aches, headaches, decongestion, coughing, sore throat, or even a loss of smell or taste. A lot of people have also developed pneumonia through COVID-19, and a lot of older people and those with underlying medical problems like cardiovascular disease, diabetes, chronic respiratory disease, cancer, things like that, they're more likely to develop serious illnesses that cause problems that go along with that COVID-19 and ultimately could result in death. So far, there have been over 191 million cases reported globally, and about 4.9 million deaths have been reported globally as well today. There is a vaccination that scientists have recently come out with, but currently there's a Delta variant that's going around that has caused quite a bit of reinfection for people who thought that they were immune to it. The best way to prevent and slow down the transmission of COVID-19 virus is to really understand the causes of it and how it spreads, and really inform yourself. You should protect yourself and others by washing your hands, practicing good respiratory etiquette, and most importantly, stay at home when you feel sick. Don't go to work, don't go to school, stay home, take care of yourself, and get better. Don't surround yourself with other people. Social distancing is a must. According to the International Atomic Energy Agency, reverse transcription polymers chain reaction, aka RT-PCR, is one of the most accurate laboratory methods for detecting, tracking, and studying the COVID-19 coronavirus. And the way that works is the chain reaction in a laboratory technique combining with reverse transcription of RNA into DNA and amplification of specific DNA targets using polymers chain reaction. It's primarily used to measure the amount of a specific RNA. Some viruses, such as coronavirus, which cause COVID-19, only contain RNA. And what that means is that they rely on infiltrating healthy cells to multiply and survive. Once inside the cell, the virus uses its own genetic code, RNA in the case of coronavirus, to take control and reprogram the cells, turning them into really just virus-making factories. In order for a virus like COVID-19 to be detected early in the body is by using that RT-PCR test that we were talking about a little bit earlier. So by doing that, scientists need to convert the RNA to the DNA in the process called reverse transcription. They do this because only DNA can be copied or amplified, which is the key part to this real-time RT-PCR process detecting viruses. So scientists amplify a specific part of that transcribed viral DNA hundreds of thousands of times. The amplification is important so that instead of trying to spot a small amount of the virus among millions of strands of genetic information, scientists have a large enough quantity of the target's sections of that viral DNA to accurately confirm that the virus is present. a sample collected from parts of the body. So how this all starts, I should say, is a sample is collected from parts of the body where the COVID-19 virus likes to gather. So the back of the throat, your nasal cavities. A lot of the times, they'll take a swab and get it right up there in your nasal cavities. Cavities. It's definitely not comfortable, but it's the most accurate. So after the sample is taken, it's treated with several different chemical solutions that remove substances such as proteins and fats that and these chemicals extract only the RNA that's present on the sample. The extracted RNA is a mix of the person's own genetic material and, if present, the virus's RNA. So the RNA is reverse transcribed to DNA using a specific enzyme, and the scientists then add additional short fragments of DNA that are complementary to specific parts of the transcribed viral DNA. If the virus is present in the sample, 3 fragments attach themselves to target sections of the viral DNA. Some of the added genetic fragments are used for building DNA strands during amplification, while the others are used for building the DNA and adding marker labels to the strands, which is then used to detect the virus. The mixture is then placed in the RT-PCR machine, and the machine cycles through the temperatures, heat and cold. The mixture is to trigger specific chemical reactions that create new identical copies of the targeted sections of viral DNA. And the cycle is repeated over and over and over. And each time it doubles from the previous number. So for example, 2 copies become 4, 4 copies become 8, and so on and so forth. So with that standard RT-PCR setup, it'll usually go through about 35 cycles. So that means by the end of the process, there's about 35 billion new copies of the sections of the DNA that created each strand of virus are present in that sample. And then as new copies of that DNA sections are built, the marker labels attach to the DNA strands, and they release a fluorescent dye. And that is measured by the machine's computer and presented in real time on the screen. The computer tracks the amount of fluorescent sample after each cycle. Which certain level of fluorescent is surpassed, that confirms if the virus is present. And scientists will also monitor how many cycles it takes to reach this level in order to estimate the severity of the infection. The fewer the cycles, the more severe the infection is. So that's also really important in determining how bad the infection is, how recent it is, and that sort of thing. So I hope after this video you have kind of a better idea of what COVID-19 is, what the symptoms are, what you can do to prevent the spread of it, what a COVID-19 test looks like and how it works. And I hope that I may have cleared up a little bit of information for you. And I hope you got a good takeaway. Have a good night.